Hi, welcome to another lesson at EduSolutions Institute. Now, today we'll be looking at the CSEC chemistry, where we are continuing on our previous lessons of learning about chemical equations. We did the solubility rule, and we looked at how to write our simple chemical compounds. Now, in today's lesson, we'll be taking this knowledge a little bit more, and we'll be looking at writing formulas based on the symbols or based on the words. Now, these first set of equations are based on words. Now, what we're realizing here is that we have different symbols. We have a plus sign, we have an arrow. What do these mean? Now, the first thing is that the parts on the left are called the reagents. These are what we are putting together, and then what is behind the arrow are the things that will be produced. So we call them the produce, right? So we have the reactants and we have the products. Now, the reactants and products are separated by the arrow. So on the left side, we have the reactants. Those are what you're mixing. The plus sign is there to show that there's a difference between these two substances. These are what we add together. And then what's on the right are products, are forms. If it's one product or more than one product, it's separated by a plus sign. So let's look at the first one. We have some symbols here. What we're going to do is to write out in words what these equations are telling us. So the first thing here is that the first one tells us that Na2O plus H2O. So the first thing is that what is this Na2O? We notice that we use two elements, the Na and the O. So that means that we go the first one first, which is sodium or Na, and it's O, so that means it's oxides, sodium oxide. And we can say and plus, and H2O we know is water. So sodium hydroxide and water will produce, and that's our arrow, Na, and then we have O and a H. Now, by last week's lesson, we know that OH together is called an hydroxide. So therefore, the product that is formed is sodium hydroxide. Right? So in words, this is what it's telling us, that sodium oxide, when it reacts with water, gives you a solution called sodium hydroxide. All right, the second one, we go with C and S. So we know C represents carbon and S represents sulfur. So this is carbon sulfide. And we have O2, and O2 is our oxygen gas. And then this will give us CO2, which is carbon dioxide, and SO2, and that gives us sulfur for the S, di, because it's two oxygen, and then oxide. So dioxide means we have two oxygen there, just like carbon dioxide for CO2. Next, we have NaCl, which is sodium chloride, and Ag here is silver, and NO3 we know from our list last week will be nitrate. So sodium chloride and silver nitrate given sodium nitrate and silver chloride. So notice these are very simple to read as chemical equation in terms of what is really happening. All right, now if we go to the next page, we will have some more. All right, we're going to do these, and then I'll give you some. All right, so these on this page I'll ask you to write down the two last ones, and you can give your answers in the comment section below, and I'll tell you if you're correct or what changes need to be made. So let's do the first one, and this is H2, and this is hydrogen gas. So hydrogen gas and Cl2 is chlorine gas, gives HCl, and it's in the gas stage, so that is called hydrogen chloride gas. All right, so what I want you to do is to do these two, right? And you can see and put your answers in the comment section so I can verify with you on those answers. Now let's go to the second one, the last two sets here, and this one is H2SO4, and this is called sulfuric acid. And sulfuric acid is not mixing with anything, so it's producing something, so that means it's going to be decomposing. And it's going to give SO3, so we can call that sulfur trioxide, and it's a gas because we have the G beside it, and water, H2O. Right? So notice, because we only have a reactant of sodium sulfuric acid, and it gives two things, then this is a decomposition. It's breaking apart to create two smaller things. This one is CH3OH, which we call methanol. It's a type of alcohol. So methanol and oxygen gas. By this, we should remember types of reactions. This is a type of combustion, so it's going to give carbon dioxide and water. All right, so as you can see, just looking at symbol forms, we can always easily interpret these symbol equations into the worded equation that tells us exactly what is happening in these reactions. Now, let's look at some word ones. So we have some worded ones. All right, we're going to do some, and then I will ask you to do the remainder ones, and you can leave your comments below on the answers you have. So in this one says sodium combines with chlorine. So we're going to go that sodium is Na, and it combines with chlorine, which is Cl, to give NaCl, which is sodium chloride. But what's missing is that chlorine exists as a gas, so that's Cl2, right? Sulfur here, sodium, sorry, is a solid. This, which is a gas, and it will give us sodium chloride, which is a solid. All right. Next one is when solid copper reacts. So we're going to have copper in its solid state. It reacts, so we put a plus sign, aqueous silver nitrate. So silver nitrate is AgNO3. Right, and it's aqueous, so we put AQ as its state, and it produces, so we go with an arrow, aqueous copper 2 sulfate, copper 2 nitrate, sorry. So that's copper nitrate in here, and then bracket 2, it's aqueous, so we put AQ, and it gives us the silver metal, so metal would be in a solid state. All right, our next one is solid iron 3 oxide. So iron is Fe, so it's Fe2O3, and this is solid, and carbon monoxide, so CO, and it's a gas to produce, so that's an arrow, iron metal, which is Fe, and it's S for it because it's a metal, and carbon dioxide, so it's CO2 gas. All right, now next is sulfuric acid, which before we know is H2SO4. This is aqueous. All gases, all acids are aqueous. And sodium hydroxide, that's also an aqueous solution. And it gives you sodium sulfate, so that's Na2SO4, aqueous, and water. And water is in liquid stage here. So as you can see here, we easily can write these chemical formulas based on the words, right? The hardest part is to know what is a compound, what's the formula for the compound that is being mixed and that is being produced. And if you're not sure of it, you can pause this video and go back to my previous videos where we did examples of how to know how to create these simple compounds using principle of ion transformation or ion switching. All right, let's continue. We're going to do these, and I'll leave these two for you to try on your own. So this number 5 here says sodium carbonate. So that's Na2CO3 decomposes. So that's going to be a solid, decomposes. So put an arrow to produce sodium oxide, Na2, and carbon dioxide. This is a gas. Sodium oxide, we can say solid. Or question 6, carbon dioxide, CO2, gas, reacts with solid lithium hydroxide to produce, so arrow, solid lithium carbonate, so CO3, this is solid, and water. And water again is in the liquid stage. Ammonia gas, so that's NH3, it's gas, reacts with oxygen gas, so O2 gas, and it produces nitrogen monoxide, so that's NO, and that is a gas, and steam, which is just water in gas state. All right, and the final one for me to do is solid ammonium nitrate. And it's a solid, decomposes into dinitrogen monoxide. So that's it's 2 nitrogen and 1 oxygen. All right, and it's a gas, and it also produces water, which is liquid. Right? So notice that it's very easy to understand the formula of the words, to translate it into the symbol formula once you understand how to create the different compounds. So again, guys, please pause this video if you're unsure. Go back to your previous videos so you can understand how to create simple chemical formulas. All right, and then I want you guys to try this one on your own. And then you can leave your comments with what you have for your answers so we can actually confirm with you if you are right. So I hope you understand a little bit more on writing chemical equations. Next class, we will focus on balancing these chemical equations, because as we have it now, these formulas or equations are not balanced. So we need to balance them to know exactly how much of each substance we need to create these new products, or how much of these new products are created from these specific amount of reactants. So that's it for today, and I'll see you guys next week. Thank you.